14th technology is edge computing. Billions of connected devices will be generating data at an enormous pace that will stress the limits of data centers and networks. When we get into the world of IoT, we will have so many connected devices. The prediction is 50 billion connected devices by 2020. And the cloud is going to be the key element of this connected world. As more and more devices are sending data to the cloud, there will be an increase in latency between the cloud and the edge devices and the communication between them. A lot of real-time critical applications need data at a very fast speed to make decisions. The latency of the cloud may not be acceptable to search applications. Such challenges are being addressed through edge computing solutions, which work alongside the cloud computing technology. A part of the storage, processing, networking, and analytics is brought closer to the edge device through edge computing solutions. The advantages of edge computing is better performance because of low latency, faster response time, again because of low latency, and more innovation because now you have many avenues to add new elements to the solutions. Growth of 5G makes it possible to have both edge and cloud computing solutions work with each other to deliver seamless user experience. As we move into 5G, a lot of applications will be a combination of cloud and edge computing. Let's understand the logic of edge computing solutions in detail.
In the future, various information and things will be connected to networks, and we expect it will be. People can now live more convenient and comfortable lives. And with things coordinated together and coordinated with information, it's expected that even more value will be created. At NTT, we're always leading this field, and by staying one step ahead, we will usher in a future that provides new value for everyone. When various information and things are connected to networks, it's referred to as the Internet of Things, or IoT. And huge, varied, and incomplete data generated by IoT need to be processed and responded to in a very short time. Today, the cloud has become an indispensable part of that process. However, the cloud that's been centrally deployed on a global scale needs to process an enormous amount of data. In addition, as the physical distance between the user and the cloud increases, transmission latency increases with it, increasing response time and stressing out the user. On top of that, the processing speed in this environment is largely dependent on the performance of the user's device. The solution to these problems is the edge computing platform. The edge computing platform works by allowing some application processing to be performed by a small edge server positioned between the cloud and user, and crucially in a location physically closer to the user. This allows for some of the workload to be offloaded from the cloud or user's device at a location closer to the user for processing, while speeding up applications that require a low latency response. A good example of an application is a web browser. Web browsers are currently one of the most widespread applications in use by businesses and private users. According to a Cabinet Office survey, when PC users were asked what they were doing on their PC, 95% responded that they were using the Internet. When asked for what, responses included watching videos, research, and downloading data, things done in a web browser. And in recent years, web browsers have been operating on more and more devices, from set-top boxes and stick PCs to digital signage displays. Yet the usability and display speed of a web browser is heavily dependent on the device's performance, and if it's not up to the task, the wait can be stressful. So, to reduce that stress, NTT has developed a web browser that offloads part of the workload to an edge server. Using a stick PC, let's compare the display speed of a standard web browser with a new one developed by NTT. As you can see, websites with complex processing like JavaScripts and websites with lots of images in particular load faster in NTT's newly developed browser. And because the web browser's processing is now being performed on the edge server rather than the device itself, the device's performance mostly becomes irrelevant, allowing support for a wide range of devices. In the near future, various information and things will be connected to networks, and they will collaborate with each other without us being conscious of them at all.